Okay, our next method for factoring is factoring by grouping. Pause and write that down. Now, the operative word here is grouping. If we look at this problem, problem number 1, and we see like, okay, first step of factoring, look for a common factor. So I see a common factor in all those terms, but the 8 doesn't have an x attached to it. And I see a 2, a 4, and an 8. Those all have a common factor, but the x cubed doesn't have a factor of 2. So what I'm going to do is I am actually going to group these together. So I'm going to make them into two groups, x cubed minus 2x squared plus 4x minus 8. Now, hopefully you agree that that is equivalent to this. I've just spaced them apart. I've literally just grouped them. And now when I look for a common factor in the first part, I notice that x squared goes into both of those. So I'm going to factor out an x squared. And when I factor out an x squared, what I'm left with is x minus 2. Okay, next I'm going to look at this group over here and look for a common factor. And I notice it has a common factor of 4. So I'm going to factor out a 4 from both of those, and look at what I'm left with, x minus 2. Now, when I look at these two groups, I notice that they both have a common factor of x minus 2. And so here's the thing that's hard to wrap your head around. I am actually going to factor out, I'm going to pull out the common factor x minus 2. So I'm going to get x minus 2 over here, and then I take what I'm left with, x squared plus 4. And then this is my answer. And if you're not sure, if you don't buy it, guess what? You can multiply it out and check. I'm going to do let's do purple for my check. X times x squared gives me x cubed plus 4x minus 2x squared minus 8. Put that in descending order, x cubed minus 2x squared plus 4x minus 8. That's what I started with, so it checks out. These two are equivalent. The quantity x minus 2 times x squared plus 4 times x cubed minus 2x squared plus 4x plus 8. It might be worth noting that this here looks like it could be a difference of two squares, but it is not factorable because there is a plus sign right here, not a minus sign. Okay, let's move on to our next example. Here we go. 6x cubed plus 30x squared plus x plus 5. Pause the video, see what you can do with this. Come back when you have an answer. Okay, we're back. Hopefully the first thing you did was group them. This is, after all, factoring by grouping. And then let's see what common factor we can take out of here. Well, I notice they have a 6 and an x squared, so I'm going to factor out 6x squared. That leaves me with x plus 5 plus, x plus 5 here. Now, since there isn't anything that I can factor out, what I am going to do is factor out a 1. And the reason why I do that is because I need two multiples so that I can factor out the x plus 5. I factor out the x plus 5 and I am left with 6x squared plus 1. Now, if you don't factor out that 1 and you just have 6x squared, let me change this to red because this is a common mistake people might make. If they forget to factor out the 1, they might just have 6x squared times x plus 5. But look at what happens when you multiply that out. You only get 6x cubed plus 30x squared, and you don't have the rest of that function there. So you need to have this plus 1, and when you multiply it back out to check your work, you get 6x cubed plus x plus 30x squared plus plus 5, reorder it, 6x cubed plus 30x squared plus x plus 5, and it checks out. So we know we're right because when we multiply it back out, we get the same answer. All right, let's look at another problem here. Okay, so let's say we have this one right here. We're going to factor this by grouping, same method, and why don't you pause the video and see what you can do with this. Do your best. Okay, we're back. And we're back, that means that you at least grouped these together. And I'm going to still put a plus sign. I'm going to treat this as negative x minus 3. Okay. Now, I'm going to see what common factor I can pull out from here. I notice I can pull out an x squared. So I have x squared times x plus 3 plus some number. Now, the trick here, notice I have an x plus 3 here. I am trying to get the other one to be some number and x plus 3, because the only way that this works is that these two factors are the same. That's why I can factor them out. Here we had x plus 5 and x plus 5. Here we had, up here we had x minus 2 and x minus 2. So we're aiming to get the same thing. So what do I need to factor out to give me an x plus 3? I need to factor out a negative 1. Negative 1 times x is negative x. Negative 1 times 3 is negative 3. And then I factor out my x plus 3, and I get x plus 3 times x squared minus 1. But, oh my gosh, it's my favorite thing. My favorite thing is when I factor, and then I get to factor again. Factoring within factoring, inception. Notice that this is a difference of two squares, that when we factor this, we're going to get x plus 1 times x minus 1. We learned a fancy name for that. We called those conjugates. So this problem, oh, it's beautiful. It's x plus 3 times x plus 1 times x minus 1. Oh, I love it. Now, technically, you could absolutely multiply this back out to check. Let's do it. Let's not skip. All right, now when I multiply these, I get x squared minus 1. Then I'm going to multiply that by x plus 3. Now, if you prefer, you can most certainly reorder this and say that this is x plus 3 because, you know, you can multiply in any order that you like. And when you multiply it back out, you get x cubed plus 3x squared minus x minus 3. Ta-da! You did it. Victorious. All right. Now, I don't know if you remember, because this was a couple weeks ago, and in pandemic time, that means it was like a year ago, we talked about another way to factor trinomials. And so I want to show you another way that we can factor trinomials. We can actually factor trinomials by grouping. Now, when you look at this problem, you're probably like, oh, but this one, why would I factor it by grouping? It's so easy. It's x plus 3 times x plus 2. And I know it's x plus 3 times x plus 2. 3 times 2 makes 6, and 3 plus 2 makes 5. But I want to show you something cool, and then that leads us to understand the concept better when we try a more difficult problem. Don't you agree that x squared plus 5x plus 6 is the same as x squared plus 3x plus 2x plus 6? 3x plus 2x makes 5, right? Well, wouldn't you also agree that we could factor this by grouping? Considering this first part here, we could factor out an x. And get, let's just start all over there. We would get x times x plus 3. And looking at this second group, we can factor out a 2, and we would get 2 times x plus 3. And then we can factor out the x plus 3's, and we would get x plus 3 times x plus 2. Yes, hopefully you agree with that. Well, that can help us on a problem like this, where we have a number, we have a, and we have to factor it. And previously we had talked about, using the guess and check method for factoring this. So we could think about, well, what multiplies to make 7, 7 and 1, what multiplies to make 8. We could do 8 and 1, or we can do 4 and 2. And then we'd have to test a bunch of options. Well, dear students, there is another way. You can factor this by grouping. And the first step is to think about how you're going to break down these middle terms. This middle term, how would you break down 30? And the way that you do it is to first multiply A and C. So when we multiply A and C, 8 times 7, we get 56. So our middle term needs to be numbers that multiply to make 56 and numbers that add to make 30. And you might be thinking, okay, well, 8 and 7. 8 and 7 multiply to make 6, but they don't add to make 30. They add to make 15. So let me try my next round. I'll take, how about 14 and 4. 14 and 4 multiply to make 56, but they only add to make 18. So I'm getting closer. Maybe if I try 28 and 2. 28 times 2 does make 56. Look, and it adds to make 30. So I found my numbers where I'm going to have my common factor. So I'm going to, let's say this is 8x squared plus 28x plus 2x plus 7. So you see that these two are equivalent expressions because 28x plus 2x makes 30x. So now that we split it up, now we can factor it by grouping, looking first at this group and looking second at that group. So see the magic unfold. The common factor between 8 and 28 is 4. So I'm going to take a 4 out of both of those. And what I'm left with is 2x squared plus 7. Oops, my bad. Not just 4, but how about 4x? If I take out 4x, I'll be left with 2x plus 7. Plus, now here I already have 2x plus 7, so I'm going to have to factor out a 1, and then I'll get 2x plus 7, because I want to be multiplying a binomial times a binomial. And look at this magic here. I have 2x plus 7 times 2x plus 7, so I can factor out my 2x plus 7 and call this 2x plus 7 times 4x plus 1. And if you're not sure that you buy that, you can multiply it out and check. 2x times 4x, 8x squared. 2x times 1, 2x. 7 times 4x, 28x. 7 times 1, 7. And look! Doot! Doot! Same thing. And so we can say, yes, this is 8x squared plus 30x plus 7. The math checks out. We're happy. All right. Now, if you were wondering, well, what if I wrote it like instead of the 28 and the 2, what if I wrote it instead 2 and 28? Would it still work? Yes, it would. So if you said 8x squared plus 2x plus 28x plus 7, you're still going to have common factors here and common factors here. So it doesn't actually matter where you place those middle terms. And if you'd like, you can keep factoring and see if you get this. Spoiler alert, you will.